Hello and welcome to a review of SOL 8.6a, slope of a line. And what we're going to talk about actually is not right away slope of a line, but actually what we use to graph a line. And so the big equation we use is y equals mx plus b. And this is known as slope-intercept form. And you might be saying to yourself, there's no numbers. And I agree. This is called a general form of the equation. So a general form means that it's kind of universal. It can be used in a lot of different ways. And if we were to make it a specific equation, we would add numbers. Now, what do these letters actually mean? Well, m is the actual slope of a line. And it's usually written as a fraction. And we'll talk more about that fraction in a minute. B is the y-intercept. And you're probably saying to yourself, why didn't they make y the y-intercept? And that's a tough argument to refute. However, you're going to see that y, and in fact x, are used as points on the line. And the reason they're actually going to stay as x and y is because there's an infinite amount of points on a line. For instance, if I were to draw just a very basic graph right now, there's a point, 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 there's a point. So you can see that, hey, there's a lot of points on a line. And so they leave it because this could be anything as long as it's a point on the line. All right, so let's take a look at kind of two examples, and then we'll jump into an SOL problem. So here we have y equals just 2x. Okay, well, the slope would be 2, so m would equal 2. But I was mentioning earlier, we always want to write slope as a fraction. And the reason is, when you get into it, it has to do with how you graph it. And I'll show you in a second when we get to a problem. The y-intercept, there isn't anything. Nothing's being added. Well, there is something. It's 0. Whenever you're not adding or subtracting something, it's indeed 0. So we can actually write out the two pieces, and we can graph like that. Now, in terms of slope, there's actually 4 types of slope. There's a line that goes like this, kind of similar to what I drew last time. There's a line that kind of goes down like that. There's a line that goes even keel like that. And then there's a vertical line. And all 4 of these have different descriptions. So the first one, and these are all kind of types of slope. So types of slope. The first one is positive. And the reason it's positive is because when you go up, it's going up as well. You can think of it like a ski lift or an elevator. Not elevator's not a good idea, but ski lift. You know, a ski lift gets you going up the mountain in a positive direction. You're gaining height. Now in this case, m would be a positive number. All right, and if you're going up, everything that must go up must also come down. So that would be negative. Think of that like the avalanche coming down the mountain. Most avalanches, actually like 99% of them are bad. And in this case, m would be negative. It'd be a negative number to come down. Now here, it doesn't go up, it doesn't go down, it remains flat. Well, the slope of that is 0. It doesn't have a slope. So m would actually be the number 0. Pretty cool, huh? Easy to remember too. Flat is 0. No elevation change. This one on the end. This is a very special case. It almost kind of deserves a star next to it, if you will. So what this is undefined. Okay? And m, well, actually, m doesn't exist really in this problem. So what happens here with the undefined problem is the line is going straight up and straight down. In fact, all of these can be written as y equals mx plus b, y equals mx plus b, y equals mx plus b, except this guy. He screws everything up. The only equation that this would work for is x equals a number. That is a very special case. So when you see a vertical line, it's actually undefined slope. You can't define it. And the equation, instead of being like y equals mx plus b, it's going to be x equals a number. So you got to watch out for that. All right, let's take a look at a graph. So here we go. Which graph best represents the equation 4x plus 5y equals negative 20? All right, amateur mistake that a lot of people like to make. They always say, here's the slope. No. No, 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 no. This can't be the slope because this is not solved for y. It's not in y equals mx plus b form. So you don't know the slope yet until you rewrite this equation. So here's what we're going to do. Off to the side, I'm going to rewrite the problem. 4x plus 5y equals negative 20. We're going to put in a little bit of work here, and we're going to solve for y. So first, we're going to subtract any terms that don't have the variable we're looking for, which is 4x. So 5y equals negative 20 minus 4x. Then we're going to split apart 5 times y, and we're going to divide everything by 5. So 5 divided by 5 cancels out. Y equals, hey, now it's looking pretty good. It's looking like what we need it to be. Negative 20. This is the part where we need to split up this big fraction. We're not really a big fan here. So we got negative 20 divided by 5. That's negative 4. And then we have minus 4 divided by 5. That doesn't really clean up, so we're going to leave it like that. All right, 2 things we need to pull from this. We need the slope, which is, in this case, it's going to be negative 4/5. Whatever's touching the x, whatever's multiplied the x, that's the slope. And our y-intercept in this problem is negative 4. All right, so you always want to start with the y-intercept. And the reason is, you can think of it like getting in a moving car. It's not really a good idea to jump in a car that's going 60 miles per hour. It usually doesn't end well for us humans. You want to get in a car that's like parked. You need a starting spot. So what we're going to do is look at the 4 graphs and see if any of them start at negative 4 on the y-axis. So let's take a look at A. It should start at negative 4. And it does. So A is possible. Let's take a look at B. B also starts at negative 4. C. Uh-oh. She doesn't start at negative 4. In fact, that's not even on the line, so C's out. And let's take a look at D. Oh, no. Same problem. D's out. So now you're just to A and to B. All right. Before we move on, I want to talk about this slope again, this negative 4/5. Now, I know a lot of math teachers would be mad if I didn't talk about this, but slope is rise over run. Rise, you could think of like a hot air balloon. When they pull the chain to make the fire blow inside of it, it would go up. That's a positive thing. But if they don't continue to blow the fire in it, it goes down. It's negative. So whenever you have a positive or a negative number up top, if it's positive, it goes up. If it's negative, it goes down. On the bottom, you can think of it like when you're going forward in life, that's positive. But when you go backwards in life, it's negative. So whatever these numbers are, they tell you what to move. We had negative 4/5. So since we had negative 4/5, the negative 4 tells me to go down 4, and the positive 5 tells me to go right 4. So let's start with A. All right, so we would go down 4. We can't do that. Well, we actually learned this before. You can go backwards. So instead of down 4, right 5, we can go up 4, left 5. So let's do that. 1, 2, 3, 4. 1, 2, 3, 4, 5. And you can see this is still a point on the line. Well, that's because that's the answer. If we tried to do that for B, 1, 2, 3, 4, 1, 2, 3, 4, 5. Uh-oh, that's not on the line. One other kind of quick shortcut you could have done. If you noticed, our number was negative. And if we go back to when we drew the quick graph, any type of negative line down here, the number has to be negative, so this line has to be sloping negative. The only difference between A and B, A was a negative line, B was a positive line. So therefore our answer had to be A. Thanks for watching.